All right, let's solve for k and q, okay, where k and q are all integers, positive integers, okay. So k and q belongs to this, so they are all positive. Solution. So we have k squared minus q squared equals to 30. Now, when we're given a squared minus b squared is the same as a plus b, a minus b. All right. Now, a plus b and a minus b, a plus b is more than, a plus b is more than a minus b. Okay. Now, if a is 2 and b is 3, this side will be 5, okay, and this side will be minus 1. So let's understand that. So we can fully write this one as k plus q, k minus q equals to 30. Now 30 can be written as, so we have 30, so 30 can be written as 30 times 1 or 1 times 30, 15 times 2 or 2 times 15, 6 times 5 or 5 times 6. Okay. 3 times 10 or 10 times 3. Okay, that's order. All right. Now, because k plus q is more than k minus q, so some will vanish from there. So 30 correspond to the k plus q. So this one will stay. This one will vanish. 15 is more than 2. 2 is and 15. 6 is more than 5. This one will vanish. This one will vanish. So 10 and 3. So we have 1. So these are the pairs. Okay, let's look at the parent. K minus q. So we have 30 times 1, 15 times 2, 6 times 5, then 10 times 3. So let's observe them one by one. So let's start with 30 times 1. So it means this one corresponds to this, and this one also corresponds to that. So I have k plus q equals to 30, then k minus q equals to 1. So we have equation 1 and equation 2. So looking at this, when we add the two equations, the k will vanish. So we have 2k equals 31. So my k here, that is the first solution, is 31 on 2. So using any of the equation, k minus q equals to 1. K minus q equals to 1. But k is 31 on 2 minus q equals 1. Multiply through by 2. So that will be 31 minus 2 equals to 2k. So we have 29 equals to k. Therefore, k will be 29 on 2. So we have the first solutions. Okay, so we have the first one. So we are done with this. Let me circle it. We are done with this 30. Okay, now let's look at the next one, 15 and 2. So k plus q equals 15, equation 3. Then k minus q equals to 2, equation 4. So let's add them. That will be 2k. So this side will go equals to 17. Therefore, k is 17 on 2. So to find q, this side will be 17 on 2 minus q equals 2. So we have 17 minus 2q equals 4. So 17 minus 4 equals to 2q. So we have 13 equals to 2q. So q will be 13 on 2. So 17 on 2, 13 on 2. That is 15 and 2. So we are done with that. So this one is also gone. Now let's look at the last but one, 6 and 5. 6 and 5. So k plus q, 6, k minus q equals 5. So we have equation 5 and 6. So let's add. That will be 2k equals to 11. So k is 11 on 2. Using the 6 one, we have 11 on 2 minus q equals 5. Multiply through by 2, 11 minus 2q equals 10. Therefore, 2q is same as 11 minus 10, just 1. Q is half. Okay, so that's that. Now let's look at the last solutions. So 10 and then 3, 10 times 3. So k plus q equals to 10, 3. So we have 7 and 8. So let's add 2k on this side we go, 13. So k is 13 on 2. Now let's use the equation 8 to solve for q. So if I plug in 13 on 2 here, minus q equals to 3. So that will be 13 minus 2q equals to 6. So 13 minus 6, 2q. 13 minus 6 will be 7. So we have 7 here. So q is 7 on 2. Okay, so these are the solutions: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so k has 4 solutions and q has another one. All right.